Good morning, everyone. I'd like to start off by saying that you may ask questions or make comments through the chat section. Type it out. I'll be reading these out to our guest speaker at the end of this presentation during the question and answer section of the webinar. I'd also like to state that this webinar will be recorded, so please turn off your camera and mute your microphones throughout the presentation. Even for question time, it will all be typed out, so there's no need to discuss through microphones. Thank you for joining us today for what promises to be an insightful and engaging webinar. We're thrilled to welcome our esteemed guest speaker from Northern Ireland, Carl Hoey, an expert in the field of railway operations and inspections. Britain has had a long-standing and fruitful relationship with Kosovo, characterized by ongoing investment and collaboration across various sectors. This partnership reflects a shared commitment to fostering growth and development in Kosovo. We're excited to see railway knowledge becoming a vital part of this investment. As we work together to enhance the infrastructure and safety of Kosovo's railway system, we believe that the transfer of expertise and best practices from Britain will play a crucial role in shaping a more efficient and reliable transport network. By integrating this knowledge into our ongoing projects, we aim to strengthen the ties between our nations and contribute to the sustainable development of Kosovo's railway industry. At Toka Training Center, we believe in the power of knowledge sharing to advance the railway industry, and we're excited to leverage this platform to foster growth and innovation in Kosovo's railway sector. We're committed to raising the bar in railway professionalism and safety. Our recent initiative has led to the establishment of a new standard of profession that's been officially approved by the Ministry. This marks a significant step forward in our mission to enrich the railway sector in Kosovo. We're dedicated to ensuring that every aspect of railway operations is meticulously accounted for, and we have plans to develop many more standards that will further enhance the railway profession. Additionally, we are actively collaborating with companies in the industry professionals like Carl Hoey to bolster the safety of Kosovo's railway network. Through a series of webinars, lectures, and tailored specialist courses, we aim to provide knowledge that will empower our workforce and promote best practices in the industry. Together, we're paving the way for a safer and more efficient railway future for Kosovo. With over 30 years of experience in the British Railway, Mr. Carl Hoey has dedicated his career to ensuring the safety and efficiency of our railway systems in the UK. His extensive background as an inspector has equipped him with invaluable insights into the intricacies of junction works and plain line inspections, the subject of today. Topics that are crucial for the development and safety of the Kosovo railway network and priority for the region now. Today, Mr. Hoey will share with us his wealth of knowledge and practical experience, shedding light on the importance of the inspections and how they contribute to the overall integrity of railway operations. His expertise will not only enhance our understanding, but also inspire us to adopt best practices in our own railway endeavours. So without further ado, please join me in welcoming Mr. Hoey. Thank you, and I hope you enjoy this session. I will mute and turn off my camera as well.
Hello, everyone. As mentioned, my name is Carl Hoey, and I've worked on the British Railways for nearly 30 years. I started my railway career as a track operative, and over the years, I worked my way up. In my 20s, I became a charge hand, and then towards my 30s, I became a track inspector. In track inspections itself, I've spent over 20 years. So starting off as a basic track inspector and then working my way up to a supervisory track inspector, which covers junction work and plain line. What I'm going to do today is I'm going to go through aspects of junction work track inspection and the stuff and processes that I would want people who I would train to look to when they're doing their track inspections. First of all, what I try to do is I try and teach all new inspectors all the components that they're going to see throughout the junction work. When they're coming to the junction work, they're going to have to know all different parts about the turnouts that they're going to inspect. First of all, on the component recognition, the inspectors will get to know different aspects of plain line and that its associated works with the P&C itself. So the inspectors will get to know the stock rails, the movable angles, which are the switch rails, and the lead rails. Through the inspections, they're then going to get to know the types of crossings and the crossing layouts that they're going to be inspecting and the purposes of the cover check rails. So when I'm training the new inspectors, what I'm training them to look for is the critical aspects of the junction work. So when an inspector comes up to inspect the junction work, he's going to have to recognize layouts and the layouts that he's inspecting. On the screen now, you have a simple left-hand turnout, and the inspectors will have to get to know all the components that are going to inspect and what also all the nominal readings are. I would expect all inspectors to know the nominals, and then whatever standards that are applicable to your railway, that's the standards that they will apply when they have gained the nominal readings. So the inspectors will do an initial 10-minute walkthrough going through the P&C, and what they're going to be looking for is any emerging substandard conditions that may require immediate actioning. So the inspectors, to have the safety of the line, they're going to be looking for broken switches, broken rails, broken joints, broken welds, anything that's going to immediately stop the traffic, broken crossings. And then what the inspectors are going to do, if in fact they have found an immediate substandard condition, is that they're going to action it straight away. And then in the event that they have not found any emerging substandard conditions, then they will start their inspection. When the inspectors have come to the crossings, they will get to know all the different components in the crossing layouts. And you can see from the slide on the screen that here we have a section of a common crossing with its cover check rail. Named are a lot of the components: the point rails, the splice rails, the cover check rails, and then you have additionally the left-hand wing. There's no right-hand wing in this picture, it's been left out. You will have the net gap and then the splice rail. What you'll always find with the fabricated common crossings is the point rail will always be attached to the most commonly used route. And the inspector, when he's inspecting the crossing, he'll be looking for major defects. So he's going to be looking for any cracks or breaks, any loose, broken, missing, or damaged components within the crossing layout itself. He will also do a full inspection from the wing rail fronts until the heels of the crossing. And every fault that he'll find, he will record on his paperwork, because every inspector will have with him a copy of the previous inspection. So he is already aware of a lot of the defects within the P&C. So what he's looking for is new defects within the P&C. Next, we have cast crossings. Cast crossings themselves are subject to different inspection regimes because they're cast. So what we have is we have cast manganese and we have cast center blocks. And within the two of them, they have different inspection regimes where they will be looked at by cast crossing inspectors. But the junction work inspector can also carry out an inspection on these at the same time. And what he'll be looking for is cracks, breaks. He's going to be looking for any other associated railhead type damage. There may be corrugation, there may be squat defects, there may be wheel burns. All these defects would go onto a defect sheet that would be available at the office for the inspector on his return. When he's on site, he'll take down all the relevant information, he'll do all the relevant measurements, he'll take down the years of all the rails, he'll do a detailed diagram that will then be handed onto the defect management team. We have defect management teams that will take care of everything for us. The only defect that would be immediately actioned would be a crack or a break, and then the inspector himself would apply the mitigations. He may take a route out of service, or he may apply a speed restriction depending on the length and type of the defect. Here we have another style of crossing layout. This is the obtuse crossings. And you can see everything is clearly numbered from the check rails to the wing rails to the left hand point, the right hand point. And the interesting one here is the stagger of the knuckles. So both crossings are slightly staggered to give you true track gauge through the actual obtuse crossings themselves. And this is something that the inspector will make sure has been done. As well as taking all his relevant gauge readings, the inspector will do these from the previous inspection so that you have the consistency of the correct track gauge and the correct cant readings throughout the obtuse crossings. Next of all, we're going to go back to the switches. And within this, all junction work inspectors do a detailed inspection along the stock and switch rails. Over the years, this has been modernized, and it's been called an S1176 inspection, which is just a stock and switch detailed inspection to look at hazards that may cause derailments. So here you have listed the lengths of planing for bullhead and flat bottom switches. The planing length is clearly marked on the diagram. And here you have the diamond crossing with the two common crossings to the sides and the two obtuse crossings above and below. All good junction work inspectors will be able to recognize all different styles of junction work layouts that they're going to go to inspect. This is all captured within their mentoring processes. Here we have a scissor crossover layout. Scissor crossovers are quite common. You will always find these at terminating stations where the trains can pull into the northbound platform and then reverse out and go down the southbound road. Incorporated in the center, you'll see the diamond crossing. And within the diamond crossing, you'll have a multitude of common crossings and you'll have a multitude of obtuse crossings. On the northbound and southbound roads, these will be called saddle crossings because they incorporate 3 crossings by themselves. Next, we have a picture of the Geismar track gauge. This is the most commonly used gauge that we have for doing track gauge and track cant readings. All inspectors will attend a training course which will give them a license to provide them to use these gauges. And all gauges will be calibrated for 1 year, and also the inspectors can check the gauge on track in a self-calibrating routine, just to confirm that the gauge is within working specifications. Next, we have the headwear sideware gauge. This is the more modern magnetic gauge. which we use to monitor our headwear and sideware readings. This attaches just under the head and it will give you an accurate reading of headwear and sideware. And using this gauge, you must always make sure that there is no debris, oil or grease left on the underside of the fishing angle where the gauge is going to be put on, and it attaches to the web. The next set of gauges that the Junction Work Inspector will have, these are called the NR4 track gauges, and these are used to assess the side wear on the stock rails on P&C. So here you'll see the gauge itself for the junction work has two different sides. One side is for slightly wider 72mm rail, and the other side is for narrower 70mm rail. The easy way to know you've got it the wrong way around is that you'll be giving a much severe reading than what you should have for the style of rail that you're actually using. That's how you know you have the gauge run the wrong way. And here you have another diagram depicting the steps on the actual gauge itself. This is our NR4 track gauge. The next gauge that we're going to cover is what we tend to call it's the switch wear radius gauge. And what this gauge is looking for is that it's trying to detect a sharp gauge corner profile. So what you want to see with this gauge when you're using it along the switch rail is you want to see the switch rail contacting at point A and point B, but not point C. If it's contacting along the rail, along the side wear scar on point C, that will mean that the rail has a sharp gauge corner profile and will need to be reprofiled by the welding and grinding teams. The next gauge we have that the junction work inspector is going to use, this is called the P8 gauge. The P8 gauge replicates the profile of a wheel flange, and it will have a marker for the 60-degree line, which is the critical line for coefficient of friction that can allow a train wheel to ride up the actual switch rail and derail the train. So what we'll do with this gauge is we'll test along the switch rail, adding any hogging with the stepped gauge to allow you get an accurate reading, and we would use a 0.3mm feeler gauge with this. Next, we're going to move on to the switch itself. So we have our 5 critical hazards on the switch rails. The first critical hazard is a side-worn stock rail with a little use switch. The second hazard is the stock rail and switch rail are both side-worn. Hazard 3, the stock rail headwear is associated with a less head-worn switch. Hazard 4 is switch rail damage. And hazard 5 is the switch rail with a sharp gauge corner profile. This is where we would use our Pac-Man gauge. We want to see contact at point A and point B, but not at point C. We're going to jump onto some slides now because this inspection is our best way to prevent derailments at switches. The reason we have a lot of derailments at switches is because our trains are only designed to go straight. Once you move a train to a different direction using switch rails, the hazard then becomes the train wanting to derail. So what we do is we do these inspections so that we can be aware of any wear patterns along the rails that may instigate a derailment of a train. You can see on this diagram where you have 3 different setups. So starting at setup 1, you can see where the switch rail has wear and the stock rail has very little wear. And this would allow the 60-degree line to be very high up the switch, which could potentially lead to the train wheel riding up the switch and derailing. You can see contact status 2. The switch rail again and the stock rail are both head worn, so they're worn to the same limit. And then on contact status 3, you can see that the stock rail is now heavily head worn and the switch rail is head worn less. On this style of defect, the potential is for the train wheel to enter the switch and strike the switch before it goes into the turnout route, again causing the train to derail. So here we have hazard 1. Hazard 1 is showing the NR4 gauge being used with the stepped reading gauge. What we have as well is that we have a form that all these readings are going to go into, so every reading is captured, and there's levels of reading. So when using the NR4 gauge, it becomes noteworthy when it goes under a reading of 12 and becomes critical when it gets down to a reading of 6. And you can see from the slide, the side wear to the stock rail. On hazard 2, now you can see where the P8 gauge is being used. And you can see on this style of P8 gauge, it has only got a single line. This is one of our more earlier style P8 gauges, and they've come a long way since. Because now what they've added to the P8 gauge itself is they've added the traffic light system. So green to the upper scale is good, and red to the lower scale will be bad. I've added an additional picture of this so that you can see it on the more modern style gauge. And you can see from the second picture where both the stock rail and switch rail are both becoming side worn. So here you have the more modern gauge. This is the modern P8 gauge that we would use. You can see the 60-degree line is marked in white, and at the 60-degree line, it is still safe. Below the 60-degree line, it starts to become unsafe. So when it fails for more than 200 mil below the 60-degree line, that would be at the unsafe limit. So what you would do is you would monitor how much it fails by during your inspections, and then you would program in the relevant switch rail reprofiling before it fails. And to help the inspectors with being in from the 60-degree line, which is white, to the green zone, the inspector will know that the switch is safe and it's not worn beyond limit. Next, we have hazard 3. And hazard 3 is a head-worn stock rail associated with a little used switch. And you can see from the picture on the right where the switch rail is now projecting to the same height of the stock rail head. And this is where it is now critical. We measure the first 40 mil to ensure the first 40 mil along the stock rail is below the depth required by gauge 1. And again, when this fails, and the junction work inspector will be monitoring it to ensure that the failure is preempted before it has failed. So when it is approaching the failure limit, he will program in the reprofiling of the switch rail, because that is the remedial action for when gauge 1 is failed. The next hazard is hazard 4, which is switch rail damage. With gauge 1, gauge 2, and the P8 gauge, the inspectors must always remember to add any hogging. Hogging is the gap beneath the switch to the slide chair. So the inspector himself, when he starts this inspection, he will have recorded all of the gaps and he'll have them on his form, and as he goes along with each gauge, he'll add the gap to the gauge, and that will give him a true reading of what the gauge is telling him. For gauge 2, what the inspector is looking for is he's looking for gauge 2 to be above any damage on the switch. When the gauge is above, that tells him he has a critical aspect and that you now have the ability for the wheel flange to climb the switch and then derail the train. With all of these hazard aspects, what we're trying to do again is prevent train derailments. And you can see from the pictures the styles of all these different features that are going to induce the train to derail. So hazard 2, again, the remedial action will be to reprofile the switch, and the reprofiling may include welding of any damage. Next, we move on to hazard 5. Hazard 5, as you can see on the gauge, you can see point A, which would be the lower section, point B, which would be the upper section, and then point C, which would be right in the corner. And you can see from the first picture on your left, the tactile edge. That tactile edge is what's going to derail the train. The train is going to grab onto that tactile edge. If it's dry, it's been non-lubricated, and then the train flange wheel itself will ride up it and derail the train. And you can see from picture 2 as well, you have the same kind of tactile edge, but it's lower down the side of the switch rather than higher in the first picture. So next we're going to move on to risk assessments, control measures, and mitigations. All P&C is risk assessed. So the inspections themselves on our junction work should be carried out every 4 weeks. And the inspection managers for them areas will risk assess every set of junction work so that he has the correct time scale to do his junction work inspections. So if he's got, for instance, a brand new layout, and it's been inspected a couple of times, the inspection manager will go down, carry out his risk assessment, he'll look at all the faults, he'll assess the frequency over the junction work, he'll assess the tonnage over the junction work, he'll look at all the faults, and if he can increase his inspection regime. So rather than inspecting them every 4 weeks and you're repeating the inspection with very, very few faults ever being reported new, the inspection manager could risk assess that inspection out to 8 weeks and then out to 12 weeks. And any type of control measures needed may be if a set of junction work that is on a 4-weekly inspection and it's suffering multiple defects where you cannot reduce the inspection, you may have a loss of clips, you may have per top and line, you might have an instance where the bolts come loose more than a scheduled inspection. What the inspection manager may do is that he may implement a supplementary inspection. So the supplementary inspection could be a basic track inspector coming down, replacing the clips, tightening the bolts, and then in between the PM4's 4-weekly regime, that keeps the bolts tight and that keeps the clips from falling out, because now they're being replaced more than just standard track inspection regime could do. The next we're going to touch on is mitigations. So mitigations is what a track inspector for junction work can do on the premises that he may find a substandard condition that he will want still to continue with the service. So what the junction work inspector may do is that on the event that he comes to the junction work and he finds that the top and line has been lost through the junction work, rather than stopping the traffic, he may implement on his inspection a speed restriction, and he would implement it through the correct channels, and rather than per se the train speed being 50, he may reduce it to 25, so to allow traffic to run but still have a safe railway. And then the remedial action of lifting and packing and correcting the top and line of the track could be done by the engineering teams at the next available time. Another thing that the junction work inspector might do is that we've already noted hazards 1 to 5, which are critical for switch inspections. The junction work inspector may come down and he may find that a switch is damaged, and it's so badly damaged that he deems it unsafe to continue in service. So what he might do is that he might take that route out of service, still allowing the trains to travel over the junction work, He will scotch and clip the route, and then he will program in through the inspection manager the rectification of the damaged switch or the replacement, but still running a safe service. Another thing the inspector may find is he may come down on his inspection and there's multiple loose fastenings through the junction work. And the inspector himself, looking at these multiple loose fastenings, he may deem it's unsafe for trains to go over it. So what he may do is that he may implement cleats and tie bars to the junction work that can hold the track gauge to allow the service to continue to run. Because the maintenance may need planned in, and there may not be the available staff to do it immediately, and it may take a few days to get the men there to rectify the problems. And these are all the different styles of mitigations that may be implemented by the junction work inspector himself. The next thing we're going to touch on is long welded rail, continuously welded rail, and unstressed welded rails, and the maintenance schedules around the points. All junction work inspectors that I would mentor to go down and do junction work inspections, I always teach them to always be aware of the associated plain line track. Now, he may have long welded rail, he may have continuously welded rail, or unstressed welded rail if he's near a platform. We tend to use unstressed welded rail through platform grounds. The continuously welded rail may be used between stations with the long welded rail. Now, the junction work inspector, he may have adjustment switches or he may have expansion switches, and he will be trained how to measure these to know that they're in a safe condition. So he may have to measure gaps, he may have to measure overlaps, and he has to know what the critical aspects of these are. And it's the same with the unstressed welded rail, where he will have expansion switches, he will have to measure the gaps and the overlaps, and also look at the general condition of the track. He's looking at the sleepers, he's looking at the fastenings, he's inspecting the ballast profile in the forefoot, the ballast profile on the shoulders. He's inspecting the sleeper conditions. He may have wooden sleepers, he may have concrete sleepers. The more modern words for them nowadays are bearers. I've always known them as sleepers, so I just continue to refer to them as sleepers, but you'll hear them being referred to as bearers as well. So these will all be added. Normally, the junction work inspector, he would be inspecting 20 meters in front of his junction work, and he would be inspecting 20 meters behind his junction work on both routes. And then through his junction work, he would be taking all similar inspections. He'll be taking track gauge, he'll be taking track cant, he'll be looking at the top and line through the entire junction work, and he'll also be recording all the faults on his sheets as he goes through the junction work. Okay, what I'm going to do is I'm going to go through the process of the junction work inspection itself. So part of this is if you go back to the original picture of a layout. So for this layout, of here with the simple turnout, what the junction work inspector is going to do, if he's going to inspect this set today, he will arrive at the office, he will collect all his calibrated gauges. The inspector himself, he will get a copy of the previous inspection. He will get all the paperwork. He will get any other paperwork that may be relevant to what he is going to do. He may get the track recording vehicle faults. There may be a fault bank for reported faults from non-track staff. He will gain the track staff fault bank, and he will take all this paperwork with him when he goes down the track. Then when he goes down the track, he will get permission of the person controlling the points, and he will then take control of the points. Because what he's going to do is he's now going to inspect the points. He's going to take the track gauge and cant throughout it. He's going to measure all the joints. He's going to measure the wear through the crossings. He's going to inspect the cover checks. He's going to look at the cover check gauge. He's going to inspect all the flares, the entry flares, the exit flares, and he's going to recall all the readings on his forms. As well as this, on the switches themselves, he's going to take additional measurements and additional inspections that have been deemed critical for us to do as to prevent derailments. So you'll have track gauges at certain parts throughout the switch layouts. Something that I always try and do as well is I always try to get the inspectors to have a good understanding and a good knowledge of switch mechanisms. And this is not something that he necessarily has to repair, but I like for them to actually know what they're looking at. So you could have different styles, from clamp lock to switch lock to chair lock to 4-foot electro-pneumatic, 6-foot electro-pneumatic. And it's more of the inspector having a good understanding so that if he sees any faults with these point mechanisms, he can report them quickly, have them actioned quickly, and the service has less delays when it comes to the start of traffic. So he's actually doubling up on the inspection of the signal operators. So if he finds any components loose, broken, missing, defective, he can add them to his report form and then report to the relevant departments. So as well, normally what we do is that we would look at a multitude of sets throughout our shifts, and we would report the faults, and we would, when we get back to the office, after releasing the points back to the relevant people, we would then put all the faults onto our fault bank ourselves. So the junction work inspector, he doesn't have to relay his faults. He puts them onto the system itself so that the fault bank accurately records what is found. Compared to a track inspector, he may go back to his railway yard and he would give his faults to one of his track team who would then input the faults for him. The junction work inspector and the plain line supervisory inspector, they would all add their faults themselves. Another thing that's been added over the years, because we're doing such a detailed inspection on the stock of switches, the junction work inspectors themselves are asked to clean the stocks and switches so that they can do their readings with great accuracy and also to detect any types of cracks or breaks. Now, the junction work inspectors themselves, they will be giving the correct grease to reapply, because they're going to have to degrease both switches to inspect them accurately with the P8 gauge, the NR4 gauges, gauge 1, gauge 2. So you always want to have everything as clean as possible. So the junction work inspector will have to clean and then re-grease. Now, over the years, there's been different processes for greasing the actual rails themselves. The more modern style that we're using now is that we grease the first 100 mil of the tip of the switches, 1200 mil in front, we grease 100 mil, and 1200 mil into the switch, we grease 100 mil. And that is with an Eclair approved railway grease. As well, the junction work inspector, he is now getting additionally trained. So when he's doing his stock and switch inspections, if he finds the hazards of a switch failing with the P8 gauge for more than 200 mil, or switch rail damage in more than one place and over 200 mil, the actual junction work inspector himself can then implement an additional inspection where he does a detailed switch inspection. And this can happen on the same shift. And he will then record all different aspects, from the switch hogging to gauge 1, gauge 2, and the P8, and as well the NR4 gauges. And then he will submit this for any remedial action that he may find that the switches may need. And something that I wanted to talk on was the process. So to become a junction work inspector, first a junction work inspector must start as a track inspector. And he will attend a track inspector's course, He will do that for 1 week, and then he will go for mentoring. And after his mentoring, which may take up to 6 weeks, he will then get assessed. And now during this process, he's going to gain lots of railway component knowledge. He's going to gain the start of his inspector's career with looking for loose, broken, missing, defective components. He'll learn about track design, not detailed, but he'll learn how the track should look and how everything should be put together so that he can report the faults on his inspections. And then after a period of time where he's gained enough railway experience, he will then move up to become a supervisory plain line inspector. That's where he covers all the plain line, but now doing measured, detailed inspections, similar to the junction work inspector, but on plain line. And now that he's acquired this accreditation, because he will have done also as well a 1 week's training course, he will then have attained a gauge training course. So he will learn how to use all the gauges, and then he will be mentored for a period of time until he's deemed ready to be assessed and gain his qualifications. And at this point now, the track inspector, who has become the supervisory plain line inspector, will now become the supervisory junction work inspector. So then he will now go back onto another 1 week training course. Then he will be mentored for a period of time until he's deemed adequate to do the assessment for junction work inspector, and then he will be assessed. And you think these period of times, these can be up to 7 years of the inspector's life, learning all these different skills. And then after this period is when he then gains his experience and his knowledge, which then gathers him through his years, being the next process step, which would be inspection manager after service of time. So as well, the inspector, looking at all the different types of components, the junction work inspector, as he does his inspections, he'll be looking for all different types of defects. He will be measuring, taking detailed static measurements of the track gauge through the crossing. He will be measuring the flares on the cover check, measuring the flange weight on the cover check, and then he'll also be taking the cover check gauge readings throughout the crossing itself. All these will be recorded on his form. When doing his detailed inspection through the cast crossing, he will use the previous inspection form, and all the points where he's going to do his measurements will be marked out. So he will follow the previous inspections for all cants and gauges, and he would do the same process as he would for a simple turnout when doing his inspection. Everything would be recorded on the previous inspection form, so any changes would be noted. The same would be for the obtuse crossings, exact same for the common crossing, exact same for the diamond layout. Everything is from the previous inspection. Now I'm going to move on to the discussion stage, where now that everyone has seen the process of how you become a junction work inspector, all the training that the person goes through, all the mentoring the person goes through, and then the assessments for each different level of accreditation that the person will go through. If there's any questions about the hazards, any questions about the crossing inspections, let's discuss them. I'm going to stop sharing the slideshow now, and we'll go to the questions.
Thank you, Carl. I'll read out some of the questions that came about. We'll go one by one, and then I'll let you answer each question as I read it. Does every set of points have its own unique risk assessment?
Viola, can you hear me?
Yep. Does every set of points have its own unique risk assessment? Can you hear me, Carl? Carl, can you
Okay,
hear me?
I can see the questions now.
Can you hear me?
Okay, something that is trained to all junction work inspectors is how to measure crossing angles. So, for example, the common crossing. A junction work inspector would measure in front of the common crossing 125 mil. He would measure into the common crossing along the V 125 mil, and then he would measure this distance. When he has this distance, he would multiply it by 4. And then once he has his measurement, he would round it to the nearest 500, and this would give him the angle of the crossing to confirm that it's the same on his paperwork. On the inspector's paperwork at the very back, he will have a components recognition page. On this page, he will have the installation dates for the switches, the style of switches, the style of point mechanism. He will also have the crossing, its style, and he will have its angle on the crossing. Each component will also have its installation date, and he will confirm that this is correct. The next question I have is talking about risk assessments and control measures. Depending on the nature of the hazard or the risk, how potential consequences are going to be identified or classified. Okay, what we have on our railways is we have sets of standards. Each different part of our railway, from components to dynamic measurements, all have their classifications. We have maintenance targets, which we want to keep the track within. So we want our track to always be in the maintenance target range. We're keeping it to a good standard. When the track falls into maintenance limit, which shows it's deteriorating from its normal maintenance target level that we want it to be in, we're then going to what's called have maintenance limit faults. When faults hit the maintenance limit classification, that's when we have to plan it. So me, I'm a junction work inspector. I would report the faults. I would put the faults onto the system. I would upload them to our fault bank. And then the manager who's accountable for actioning the faults, he would then see them on his fault bank. And then what he would do is that he would plan the faults in to be rectified by his maintenance teams. Another question from Viola. Does every set of points have its own unique risk assessment? The answer to that is yes. Every single set of points on the railways that I inspect have its own unique risk assessment. You would work in I work in a team of inspectors. You could have a team of 6 inspectors. If you inspected every set of points that you had on your section every 4 weeks, you could be doing a lot of inspections and struggling to keep up with these inspections because they're too onerous. Because your junction work may be in good condition and its wear rate may be very little, it's got very little wear rate, you could then risk assess your points for 8 weeks. You could risk assess them to 12 weeks. Points that are maybe in between stations that are only crossed over for special moves, they may have a very low wear rate compared to points at a terminating station that have a very high rate of wear, because every train comes in and goes out and comes in and goes out. So that could be a 4-weekly inspection compared to the points in between stations that are not used as often. They would then maybe become 8-weekly or 12-weekly inspections, which would reduce the workload for your junction work inspection team. Another question I see is, what is the planing length of a switch? Now, the planing length of a switch is what happens when the switch itself is normally fabricated from a standard piece of running rail, and what they do is that they cut the piece of running rail straight down, they plane it to fit against the stop rail, and that's what's called the planing length. As junction work inspectors, on our forms, we would have the planing length on the back of the form in the configuration data. And what we're trained to do is we're trained to measure the planing length from the tip of the switch to where the rail goes back to full head width, measure it, and then confirm that it's correct on our forms. Where this could be advantageous for all inspectors to keep up to date, to ensure that it's accurate, is that if you had a broken switch found on your inspection and you had the pro forma, which is the exact measurements of that switch held at your office, and that switch is found broken during your inspections, you could order one straight away to the pro forma, and again confirming with the inspector's measurements that it is the actual correct style planing length, the correct switch for that style of junction work. I got another question. What is the most common defect that occurs, and how do you find the angle of the crossing? Okay, I covered the angle of the crossing, but the most common defect that you could find on switches, you tend to find quite a lot lipping. Lipping occurs predominantly through the planing length of a switch. It can lip on the gauge face, and it can also lip on the back of the switch, and so can the stop rail. And these defects would probably have a 13-week time scale to be machined off, because they could give you inaccurate readings. Lipping on the gauge face itself is classified as a derailment hazard as well, and you would instantly have to make sure that the grease is correctly lubricated, so that the gauge face, you wouldn't get that coefficient of friction for the wheel to climb up the actual switch. So you have to make sure your switches stay adequately lubricated. Is there any other questions? If there's no more questions, what I'm going to do is I'm going to do a recap. Yeah, I'm going to do a quick 5-minute recap on everything that we've discussed. So first of all, we discussed junction work. We discussed the layouts and the style that people are going to inspect. We also discussed how the junction work inspectors reach the level of junction work inspector. All the training, all the mentoring, all the years of experience. We also then discussed the aspects through the P&C, the hazards 1 to 5, which are the critical hazards of the switches that the junction work inspector is going to inspect. We also discussed the additional measurements that the inspector would do through the junction work, taking gauge readings, cant readings, and also measuring the wear on his crossings. The junction work inspector will measure the wear at the half toppings, he'll measure the wear on the wings, he'll measure the wear across the wings, looking for any discrepancies that may require crossing maintenance. Crossing maintenance may be welding, crossing maintenance may be grinding. And the junction work inspector will also cover 20 meters in front of his junction work, and he'll cover 20 meters on his through route and 20 meters on his turnout route. Also, we discussed how the junction work inspector attained his paperwork. Because he's a supervisory position, the junction work inspector, same as the plane line inspector, they generate their own paperwork. It's created by them, it's monitored by them, but it's also verified by the inspection manager, because the junction work inspectors and the plane line supervisory inspectors are trained to the same level as an inspection manager. So he can verify their paperwork to say it's accurate, it's got the correct classification, may it be a maintenance target, may it be a maintenance limit, may it be a safety standard condition. So the inspection manager will confirm that the reports are correct and up to date. He will also confirm that the junction work inspector's reports are up to date, that all the inspections are being closed out in a timely manner. The junction work inspector will also have an overview of the crossings, and especially where he has cast crossings that may require additional 3 or 6 monthly inspections. They could be cast crossings, they could be cast center block crossings, they could be semi-welded, and they could also have a cast V. The cast crossings themselves fall under a separate inspection, a cast crossing inspection regime. So as long as the junction work inspector for us is aware of what that regime is and the testing they do, and he takes his wear measurements at the correct place,
Worries.
that is fine because the cast crossing.
Thank you all for joining us today for this enlightening session with Mr. Hoy. We hope you found his insights and experience on junction works and plane line inspections as valuable as we did. It's clear that the knowledge shared today will significantly contribute to our collective efforts in enhancing the safety and efficiency of Kosovo's railway system. As we look ahead, I'm excited to announce that this is just the beginning. We'll be organising a series of monthly webinars covering a range of critical subjects, including stressing, signalling, level crossings, wheel rail relationships, and safety on the track, among others. These sessions will provide ongoing opportunities for learning and development in our industry, so be sure to stay tuned for announcements on upcoming topics. We appreciate your participation and engagement today, and we encourage you to take the knowledge you've gained back to your teams and communities. Together, we can continue to advance the railway sector in Kosovo, ensuring a safer and more efficient railway for all. Thank you once again for your time, and Mr. Carl Hoy, thank you for your time especially. We look forward to seeing you in our next webinars and the audience as well.